Okay, g'day folks, welcome back to Kieran's Training. So today we're going to talk about the calculations required for the open crane licence. I know there's been a few out there waiting for it, so we'll get stuck straight into it. So with the open crane licence, we're going to look at a couple of different types of load charts. So we're going to look at the load charts for the Grove 130 and also a 250 tonne cavalcade. Okay, so we'll go through it one at a time, simple process. Right, so we'll get stuck straight into it. Okay, so I'll just move this across one at a time, so I'll get this. Alright, so to start off with, let's bring that up. Okay, copy and paste. Alright. And I'll just move this up out of the way. Don't want to see my big ugly mug on there. Alright, so we're going to be operating the Grove GMK 532 with 23.5 tonnes of counterweight and 75 tonnes of hook block. Okay, so we'll get stuck straight into questions. So the first question is we're going to figure out how much outrigger load is going to be placed onto the ground with the timbers we're going to have on. Alright, so we'll have a look at the question. Alright, we'll copy that, we'll bring it back up here. Alright, so 5130 lifting 65 tonne load. Each of the outriggers on the crane are provided with timbers that are 1.2 metres long and 1.2 metres wide. So calculate the maximum ground pressure that will be applied to the ground when lifting directly above an outrigger foot. And the answers are to be rounded up to the nearest 0.1 of a tonne per metres squared. Alright, so first thing we'll have a look at a couple of things. Alright, so we need to know the load, which is 65 tonne. Okay, now we need to work out the total crane mass, so the total weight of the crane. So I'll just pop this over here. Okay, so to find out the total weight of the crane, alright, we'll run over to our load charts. Oh, that might make it a bit harder. Alright, so don't know how well we'll see that, so I can see if I can just get that up a little bit more. Alright, so you look at your axle loadings here, and that's going to give you the total weight of your crane. Okay, so you got 60 tonne there. Okay, now you got to read the fine print. If you look underneath, that's 60 tonne. That is with 8.5 tonne of counterweight on it, so you're carrying your belly plates. Okay, the fly and a 20 tonne hook block. Okay, so to work out the weight of the crane. Okay. Let me have a look here. Okay, so what do we have? We've got the weight of the crane, 60 tonne. Alright, now before we add on the extra counterweight and add on the weight of the 75 tonne hook block, we'll deduct what's on here and then we can just replace it with the actual weights. Alright, so 60 tonne minus our 8.5 tonne counterweight. Alright, keeping in mind we are going to put the counterweight back on. Alright, and minus the hook block, which is 325 kilos. So if you look just under here, alright, our 20 tonne hook block right here, alright, that weighs 325 kilos. Alright, so we're going to deduct that. Alright, so 60 tonne minus your 8.5 minus the 325 kilos. Alright, and then we're going to add on the hook block and the counterweight that we have on it. So the hook block we've got, the 75 tonne hook block, so if we have a look over here, right, that weighs 850 kilos. Alright, so we're going to add that on. Right, and we've got 23.5 counterweight, so we're going to add that on as well. Okay, and that's going to give us a total crane mass in that configuration of 75.525 tonnes. Okay, so we've got the weight of our crane, we've got the weight of our load. Okay, now we need to take into account the area size of our timbers. Right, so we'll have a look at that. Right, let's paste that on there. Okay, so you got 1.2 metres by 1.2 metres, which is going to give us 1.44 metres squared. Okay, now to find out the total pressure being applied to the ground, alright, we go to this formula. Alright, so I'll copy that, I'll bring that over here. Alright, so there's our formula. So 0.65 times the crane mass plus the load, and then divide that by your outrigger pads. Okay, and that's going to give you the total pressure being applied to the ground. Okay, now the 0.65, keep getting asked what that indicates. Right, so it's an engineered number that someone somewhere has said at no point in time will more than 65% of the total load and crane weight be over a single outrigger. Alright, so that's where they get the 0.65 from. Okay, so just like everything else, right, all you need to do, write out the formula. Underneath that, just put the figures in. Alright, so I'll copy that. Okay, so I've got 0.65 times. Then in brackets, you got your crane mass, so your total crane mass, which was 75.525 tonne, plus your 65 tonne load. Alright, and then divided by 1.44 metres squared. Alright, so let's go down to the next one. Alright, so keep in mind you've got to remember to do what's inside the brackets first. Okay, so if you do your 75 plus your 65, right, that's going to give you 140.525 times 0.65, alright, is going to give you 91.34125 tonnes. Right, then you divide that into your pad size, alright, and that is going to give you okay, let's paste that on. Okay, so total bearing pressure down on the soil is going to be 63.5 tonnes per metre squared. Okay, so we'll just quickly cover that over again. So when you're given the weight of, when you're working out the weight of the crane, alright, remember if you're going to use more counterweight, you can take off what's on there and then add the total counterweight back on. Okay, if you didn't want to do that, rather than take off the 8.5 and then add 23.5, right, you could have just added 15 to what's already there, and that will give you 23.5 as well. Alright, same as the hooks, you can just add the difference between them if you like. Alright, but sometimes it's just easy, just take everything off, put it back on. Okay, so that's our first question. Alright, so we'll run down. So let's go on to the next question. Okay, so let's copy that. Okay, so using the same crane from the previous question, you're now set up on loose sand. What is the minimum outrigger pad area required to not sink into the loose sand? Show your workings. Alright, so I'll copy this and I'll chuck this over here. Alright, so we need to know the permissible ground bearing pressures for each. Alright, so if we're going to be on, what did I say we were on? Loose sand. Right, so loose sand, right, is going to be good for 10. Alright, so, alright, something tells me my timbers aren't going to be big enough, so let's have a look. Alright, so first up we've got the formula. Okay, chuck that in there. So your pad area needs to be what your total outrigger loading was, divided by whatever permissible ground bearing pressure you have over here, or your pressure max. Okay, so you put that in there. Alright, write down the formula, you chuck the numbers underneath. Right, so outrigger load. Alright, so if we have our 91.34125 tonnes, alright, divided by 10 tonnes per metre, alright, then that is going to give us, okay, let's have a look. Well, press the wrong button there. Alright. So our pad area would need to be, just move the decimal point across on that one, but let's go through it. Is going to be 9.134125 metres squared. Okay, now to find out what length and width of pads are going to be required, okay, what we can do then is just square root that answer. Okay, let's copy that one and we'll chuck this one down here. Alright, so dimensions of your pads, right, all you need to do is square root that answer. There you go, square root 91.34125. Oh, sorry, that should be square root of 9.1. That decimal point's in the wrong place. Okay. Okay, and that means your outrigger pads need to be at a minimum of 3.022 metres. Okay, rounding it up to the nearest is going to make it 3.1 metres by 3.1 metres. So therefore, timbers there aren't going to be big enough. So it's pretty important that you make sure you do get the right size pads. Well, most important thing about a crane is getting it set up right, okay? If you haven't got it set up right, things are going to go bad right from the start. Okay, let's keep moving. Alright. So, let's have a look. Let's copy that and go down to here. Alright, so now that you've set up the Grove with your 23.5 tonne counterweight and the 6 parts of line on the 75 tonne hook block, you then extend the boom to 27.16 metres. Alright, so that's our scenario. Alright, and we're going to go with, alright. Okay, so what is the counterweight configuration required to achieve a counterweight configuration of 23.5 tonne? Alright, so we refer back to our load chart. Okay, see if I'm going in the right direction, probably not. Alright, where are we? Here we go. Alright, so as you can see there, alright, so with 23.5 tonne, that's what we need. We need a 2.5 tonne slab, another 2.5 tonne slab, a 5 tonne slab, or 1, 2, 3, 5 tonne slabs, alright, another 2.5 tonne, and a 1 tonne. Alright, so let's copy this over here. Alright, so that's going to be our counterweight configurations there, alright? And if you look up above here on the diagram, alright, so you can see where these run. So your 11, alright, that's your backing plate, which replaces a winch that could be on there. Okay, you got your regular slabs, alright, you got your base plates down the bottom, alright, so they're all numbered so you know which ones you're looking at. Okay, so that's the sequence of counterweights you're going to need in order to achieve your 23.5 tonne. Okay, now what is the maximum and minimum boom configuration in this setup? Alright, let's put that question over here. Alright, so find the maximum minimum working radius, pretty easy thing to do. Most important thing, make sure you're looking at the right load chart, alright? If you're not looking at the right load chart, you're going to be in trouble. Alright, so we'll roll down. Alright, so you can see on all these load charts, alright, I'll just blow one of them up. Alright, so this picture here tells you you're working with your live boom. Right, that tells you your outrigger configuration. You got 360 slew, right, and that's your counterweight configuration. Alright, so we've got 23.5. So let's see if I can find the right one. Here we go, just down here. Okay, so it's pretty important you're looking at the right load chart. Alright, so let's just go back and have a look at how much boom I had out. Alright, where am I? Okay, so 27.16 meters of boom. Alright, so here's our load chart with 23.5 ton counterweight, 27.16 meters of boom. Okay, so minimum radius. Alright, basically look at the top figure in that row. Alright, so there you go, it is 3 meters. Okay, so our minimum radius is 3 meters, and our maximum radius, go right down to the bottom, right, run across, and it's going to be 24 meters. Okay, so let's just put that in here. Alright, so that's pretty easy to find that one. Alright, now just while we're going, one thing I will mention is probably if you are in a crane, right, load charts are like your Bible. If you don't understand how to read a load chart, you probably shouldn't be sitting in that crane. Alright, so they are pretty important documents to be able to read and understand. Alright, now, so let's go on to the next part, and these are very simplified. The actual load charts for this crane are a lot bigger than what you see in front of you here. Alright, so let's have a look at the next section. Alright, so copy. Alright, so no, put the answer up there. Let's put the question up first, might be easier. Alright. So the next thing we want to know is what's the maximum speed the hook block can be raised in this configuration, alright, and show your workings out. Alright, so first thing we need to know is how fast does the winch go? Oh, let's get rid of that one. So we'll scroll back up here, pretty sure it's over the other side here somewhere. Right, let's easier to see. Where's our winch speed? Alright. Okay. So there is a fair bit of information on here. Okay, here we go. Just hiding over the other side. Okay, so 2 winches. Alright, they both travel at the same speed. Okay, so winch 1 goes at 120 meters per minute. Alright, now that is with a single fall of rope. Alright, if you've got 6 parts of line in it, alright, just divide that by 6 and that'll give you your winch speed. Alright, so we'll copy that out over here and paste it there. Alright, so at 120 minutes per minute, alright, we've got 6 parts of line, so 120 divided by 6 is going to give you, that can't be right, it's got to be 20 mil. Alright, so 20 meters per minute. Alright, so the more parts of line you have in your main hook, the slower it's going to go. Okay, so now we're going to have a look at how we're going to do some derations on the crane. Okay, quite often you go to sites now, some sites may say they don't want you to lift more than 80% of the crane's capacity, 75% of the crane's capacity. Okay, so different sites do have different rules. Right, but keep in mind these cranes are designed to go to 100% capacity. But if you're on one of those sites that say 80% max, they're the ones paying the bills, they're the rules you follow while you're there. Alright, so we'll have a look at the next scenario. Alright, let's put this down here. Alright, So the site you're working on requires that the crane load chart be derated to 80%. Okay, so while the crane is still set up in the configuration of scenario 2, you're being asked to pick up 20 tonnes at an 8 metre radius, slew 170 degrees, and lower the load to a platform at 11 metres. Okay, load requires the use of 100 kilos of rigging. Okay, so what we need to do, so we need to find out our total load. Okay, so let's put that down here. So remember, our total load doesn't consist of just the load itself. You've got to take into account the weight of the hook block and also the weight of the rigging and any other ancillary equipment you may have attached as well. Alright. No, that didn't copy, so let's try that again. Okay, where are we? Copy and paste. Alright, so our total load, we had 20 kilos for the load. Right, remembering our hook block was 850 kilos because we had the 75 tonne hook block, so 75 tonne hook block, 850 kilos. Alright, plus 100 kilos of rigging, so we've got a total load of 20.95. Okay, now the crane capacity at an 8 metre radius. Alright, so at 8 metres, alright, we'll run back down to our load chart. That one, here we go. Alright, so 23.5 metres. Let's get that a bit bigger so it might be a bit easier for you to see. Okay, so 27.16 metres of boom at an 8 metre radius. Alright, means the crane is good for 41.5 tonne. Okay, now to find out 75% of that, alright, because the site only wants us to work to 75%. Right, what we've got to do is just multiply that by 0.75 to get the 75% of that total load. Okay, so let's bring this across here. We'll paste that in there. So 75% of the crane capacity, so you've got 0.75 times the actual capacity of the crane, alright? Which means you aren't supposed to go above 31.125 tonnes allowed at that particular site. Okay. Okay, so if we're looking at that, we want to figure out, well, how much of the site's total capacity is that 20.95 tonne? Okay, so what percentage of 31.25 is 29.5? Right, so what we will do is okay, so to find the percentage of the site's allowed rated capacity. Okay, so we are lifting 20.95 tonnes, so what percentage of that is to the 31.25? Alright, so quite simply what we do is we just divide one into the other. So let's copy that over here, come back down here and paste that on. So you've got 20.95, so that's your load, divided by the allowable capacity, which is 31.25 tonne on site. Okay, which means we are lifting 67% of the site's allowable capacity for that lift. Okay, so we'll come down, we'll go on to the next one. Alright, so what we'll do now is we'll take a look at the Kobelco load charts. Alright, so I will just drag this one over here. Alright, so here we go, we've got our Kobelco. Alright, and let's have a look at the first scenario we have. Let's copy that, paste it over here. Okay. So, you've been asked to operate a Kobelco CKE 2500 crawler in luffing jib configuration. You've been told that the crane has 45.7 metres of boom inserted and 51.8 metres of luffing fly on it. So you want to check the crane configuration before you begin lifting because you weren't there when the crane was rigged. Alright, so if you just rocked up and you're taking over a new crane, it's always a good idea to make sure it's actually been set up correctly. Alright, so first thing we want to know, alright, so let's have a look, so we'll paste that. So what's the total counterweight required for stable crane operation in this configuration? Okay, so the configuration was 45.7 boom and 51 of fly. Alright, so if we scroll down to the load chart for it, alright, let's keep coming down. Alright, boom arrangements. Alright, keep coming down. Alright, that's just the boom itself. Auxiliary sheaves. Okay, luffing boom lifting capacities. Alright. Okay. Alright, let's see if we can find it in here. That's a fixed tube. Alright, you don't want a fixed tube. Okay, so we've got our luffing tube. Alright, so luffing tube. Alright, we have, what did I say we've got? We've got 45.7 boom, 51.8 of fly. Alright, so you'll see your boom lengths across the top, so that's 21.3, alright, 27.4, 33.5, 39.6, okay, 45.7, alright. 45.7 and we want 51.8 metres of jib. Alright, so jibs are underneath your boom. Alright, so it must be down on the next one. So we've got 45.7, alright, and 51.8 metres of luffing boom. Alright, so counterweight required. Alright, you'll see in the top of the counterweight here, we've got 90 tonne counterweight plus the car body weights of 24 tonne. Alright, so that's going to be what we need. Alright, so let's have a look, we'll copy that and we'll chuck that over here. Okay. So our total counterweight is the car plus the car body weight, so we've got 90 plus 24, so 114 tonne of counterweight in total. Okay. Now, the most flexible configurations for the boom and jib arrangements for this scenario. Okay, so there can be several ways you can set it up, alright, but you want one that's going to be a little bit more flexible in case you do need to change it, alright. So, let's most flexible configuration, so if we run back up to the top, right, look for our boom sequence diagrams. Here we go, luffing jib arrangements, okay, luffing boom, alright, that's what we want. Okay, so luffing boom. So, if we have 45.7 metres, okay, so 45.7, alright, so we've got this one here, alright, so that's our configuration there. Let's let's just have a quick look, make sure 6, 6.1, go to 6.1, go to 12.2, go to 12.2, yep, so what we'll do, so right down here, 45.7 metres, alright, see this little indicator here, alright, that indicates it's in that configuration. Well, it's the only one in that configuration, so you don't have a lot of choice on that one, right, but that will tell you down the bottom here, it's the most flexible combination of inserting luffing booms, alright, so right here, alright, so, and it gives you your little symbols here, alright, so your little B here, right, that's your butt section, so that's 7.6 metres. Okay, then if you work your way along, right, you got little 10 here, so that's a 10-foot section, a 20-foot section, 40-foot, 40-foot. Right, so it gives you the metric measurements here. Right, so your 10s are 3 metres, your 20s are 6.1, and your 40s are 12.2. All right. So, and the luffing jib. Alright, so what did we say we had over here? 51.8 metres. Alright, so you've got two choices there for the 51.8. Alright, they want the most flexible combination, so you're going to go to the one with this little star thing here. Alright, and that's going to give you what you need there. Alright, so if I copy that and put that down here. Alright. Yep. Alright, we'll work on this little copy and paste. Here we go. Alright, so with our boom, alright, we had the 7.6 metre, we had a 3 metre, 6.1. Alright, so we roll back up. Boom. Okay, 45.7. Alright, so we had 7.6 there. Alright, 10 there, which is 3 metre. Alright, we had a 20, which is 6.1. Alright, we had two 40s, so had two 12.2 metres. Alright, your 11.7B there. Alright, if you have a look, where are we? 11.7B. Right, so that's another 3.6. And your C on the end there, alright, is going to give you the extra metre. Alright, so that's your configuration for your boom, alright, and your luffing jib. Alright, that was at 51.8. Alright, we'll go with the top one because we're looking for the one with the star here. Alright, and you just spell out what's on here. Alright, so you've got 9.1, a 3, a 3, a 3, 6.1, 12.2, and a 9.1. Alright, so looking at your boom sequence diagrams, it's going to tell you exactly how to set up the boom and the fly. Alright. So, let's go on to the next one. Alright. Paste. How many falls of rope should be on the hook block? Alright, so if you run back down to our chart, alright, down near the bottom here somewhere. Okay, 45.7. Oh. 45.7 with 51.8 metres. Alright, so down the bottom here, alright, tells you how many parts of line are in the hook block. Alright, so nice and simple, it's going to be 2. Alright, so load charts are relatively simple, it's just a matter of understanding where to be able to find the information on them. Okay. Okay, let's go on to the next one. Alright, and next one is going to be, well, 2 parts to it. Alright, so using the configuration, so we've got our 45.7 and we've got our 51.8 metres. Okay, you've been asked to pick up a 6.3 tonne load, which is including your rigging, at a 22 metre radius and place it at a 66 metre radius. Alright, so that's us. So using the configuration provided, picking it up at 6.3, 22 metre radius, place it on a 66 metre radius. Alright, so we are going to ask what is the boom angle required to pick that load up vertically, because remember, we don't want to drag or sneak the load. So we look at our load chart, 45.7 metres of boom, 51.8 metres of fly, right, and we wanted that 22 metres to pick it up. Alright, so if we run across here, alright, so we're going to have to go with that one. So our boom angle, if we have a look, is going to be at 88 degrees, right, in order to pick that up in a straight question. Alright, so chuck that in there. Alright, so 88 degrees. Okay, now, next one gets a little bit tricky. Alright, well, not really, but let's have a look. Alright, can you complete it in a single lift, and how are you going to do it? Alright, so if we're picking up from here, so that's where we're picking up from, right, and we're going to set it down at 66 metres. Alright, so we got down here, right, so 66 metres, alright, let's see if it works back the way. Alright, you got the choice of these two here, alright, 7.3 or 6.6. Alright, now, once you take into account the weight of your hook block, alright, you're not going to be able to do it here because your 6.5 tonne load plus your 2 parts on your hook block, which means you've got at least a single sheave. We would have run up the top. Alright, where are we? It's going to be in here somewhere. Alright, let's have a look. What's the weights? Okay, let's find our hooks. There we go. Alright, so 2-part hook block. Alright, that is going to be, no, wrong one. Right, let's keep running down. Let's find the weight of our hooks. Okay, so hooks, weights. Alright, so if you know we've got 2 parts of line, it means we must have at least 1 sheave in there. Alright, so we are going to have this one on, so single sheave hook block, alright, 900 kilos. Alright, so you're already lifting a load of, how much should I say it was? 6.3 tonne. Alright, so if we run back down to our chart, okay, 57, 45.7, 51.8, alright, so 66. Alright, so we've got a 6.3 tonne load and we add that 900 kilo hook block to it. Alright, that's going to end up giving us too much. Alright, so 6.3 plus the 900 kilos, right, that's going to end up giving us 7.2 tonne. Alright, which means we can't go to here to 63 degrees because we are only good for 6.6 tonne. Alright, so we're going to have to go for this one. So, how do we complete that in a single lift? Alright, so let's take a look. So you're going to set the main boom angle to 88 to allow the operator to pick it up. Alright, then you're going to luff the main boom down to an angle of 68 degrees. Alright, because we can't go to your 63 because you won't be able to get it. So you're going to boom down to 68 degrees. Okay, then you're going to luff the fly jib down in order to place it at 66. All right. So bring your main boom to 68 and then adjust your luff and fly in order to get to your correct radius. Okay. Okay, so that's just a quick look at our load charts for the Kobelco. All right. So hope this helps. All right. If you do have any questions, just leave them in the comments below. All right. Thanks for listening and have a good night.